Hello everyone, this is the second video on the tutorial series about how to use the FitMultiCell pipeline. In the first video, we talked about how you can install different tools that forming this pipeline. In this video, we will talk about the basic components that you need to have in your code in order to fit your multi-scale model. So let's start. The first component that you need to define is the model component. Your model should be compatible with Morpheus. Morpheus uses an XML format to define the models. More specifically, they are using Morpheus ML language to define the model. You can also import model in SPML format. SPML format is a widely used representation of models in the system biology domain. Here is an example of how you can define your model component. So first, from the FitMultiCell package, you will import the model module, and then from the model module, you would call the Morpheus model. This function takes one mandatory argument, which is the path to your model. Also, it takes several optional arguments, such as the executable. We will know more about these optional arguments in the next videos. The second component is to define your measurement data. The measurement data is one of the basic elements on the ABC method, or approximate Bayesian computation, which is the one that implemented in the PyABC tool, which is one of the basic components of the FitMultiCell pipeline. The measurement data would be used to see how much close the simulation is to the measurement data. The third component is that you need to define the prior distribution for all of your parameters of interest in your multi-scale model. Here is an example of how you can define your prior distribution for your parameters. In this example, we have only one parameter called the mean, and this mean parameter have a prior distribution of a uniform distribution between the values 0 and 5. The fourth element that you need to define in your FitMultiCell pipeline is the distance function. The distance function, or the objective function, is used to define how close the measurement data is from the simulated data. Many distance functions can be used, such as the L1 norm, L2 norm, and so on. Here is an example of a distance function that can be used. It is nothing but the absolute of the difference between the X and Y arrays. X could be the measurement data, Y could be the simulated data. Finally, the last component that you need to define, and this one is an optional one, is the stopping criteria. When do you want to stop your fitting process? There are multiple options that you can define that determine how you can stop the fitting process. For example, if you reach to a specific distance between your measurement data and your simulated data. Also, you could define how many iterations of population that you need to have in your fitting process, and so on. So you need to define all these components, and then you can start the fitting process. We will know more about these different components in the coming videos, and this will end our video today. Thank you for listening, and see you in the next video. Bye.